First of all, let's talk a little bit about Optane memory. And specifically, the thing that comes to my mind is the two modes of using Optane as memories. You've got memory mode and app direct mode. Is it clear to you that this is two tiers of memory, or is this just two flavors of memory? I'm going to throw that out. Who wants to jump right in and give your thoughts on memory mode versus app direct mode?
It can't be two tiers. It's the same level of performance. I mean, yeah, you're using different ways to access it, but I don't think it can be two tiers. Mike.
Yeah, to Ray's point, I mean, one is just an extension of memory, and the other one is a persistent memory, and you need APIs to work in it. So you just use it in a different way, but in the end, they sit in the same slots and they work in the same way.
Could you even say that maybe app direct mode isn't a memory tier? Is it something else? Is it a zebra?
You know, it's a support to an application. I mean, you need to write code to use it. So
but HANA and those guys are doing they're writing the code and they're using it as a memory. So it's yeah, okay. It's different ways to access it, but it's still PMEM.
No, I would say it's persistent across reboots, so it's not the same identical thing. I mean, you can extend memory, or you can have you can use it in different way. I mean, you can build pieces of your databases that are there, and then when you reboot the system, the information is still there and consistent and coherent with what you're doing. So it's a little bit different. I mean. So a different way to access memory and use it.
I think that these are different use cases, right? AppDirect, as its name, is really for specialized applications that are just given the raw device and they do what they need to do with it or the use that they find for it. While memory mode is basically the application don't want to know about it, don't want to be aware of it. They just want to rely on the caching tier of the controller itself and just enjoy large memory space.
The app direct is what we actually wanted originally. Like we used to have this with core memory, that memory was persistent, but then we had to go with DRAM because we couldn't actually do core memory at the scale and capacity that we needed. So storage is kind of it's a multi-decade mistake. But because the industry has grown up around this kind of idea of ephemeral memory, we're kind of stuck with it because all these applications are written that way and we can't rewrite all of them.
I think I'll add to, when we talk about app direct, just to add another layer in there for you, Justin, there's actually, we talk about two types of volatile app direct and non-volatile app direct. So we actually do have software and customer solutions that use app direct, but still volatilely. So, that you essentially have you can place some data in DRAM, you can place some data in persistent memory, but it's ephemeral. And then we have others that go further and actually use its non-volatile properties, right? And then it kind of gets a little bit closer to storage because something is actually non-volatilely persisting through phases.
Honestly, I kind of like that. I feel like you can't entirely put your finger on it, right? There's so many different ways to use it and different attributes that it can be so many different things to different applications. And even if your application itself, maybe it doesn't want to do app direct and have to rewrite its code, maybe it can take advantage of another library or service in the ecosystem that has been customized already to be able to take advantage of it. So I don't know, I think it's a good thing that you can't, only put it in one or two tier boxes, right?
Well, there is also another aspect that maybe we forget is that a few years ago we didn't have in-memory databases of this size. I mean, so bringing up an in-memory database from even from an SSD, and we are talking about terabytes for each single node. It's huge. I mean, especially if it's shared storage, so it's not local storage, and you have to move all this data to repopulate your in-memory database. So having a local, close to the CPU persistent memory device, it's huge. I mean, you can be up again in seconds or 1 minute instead of maybe several minutes, and this could change your SLA or whatever you need to to keep your service up. It's very late here. I lost what I wanted to say. I hope it was clear.
So getting back to the original question, is it 2 tiers or one? I think it's 1 tier. The fact that it's persistent or not persistent is very unique and is a unique capability that you can take advantage of or not based on what you need to use. Memory mode versus app direct is who wants to control what's in DRAM versus what's in PMEM. If you want to control it, then you have to use app direct. If you don't want to control it, use mem mode.
Yeah, I totally agree with that.
So this leads me to my next point, which is to ask, what about ROI of programming for app direct mode? What would you use to decide whether you want to use app direct versus memory mode? And how do you decide whether it's worth it to refactor your application?
There are so many use cases for this, as long as the use case pertains to one of the benefits of this. An example of this, I've got a Microsoft SQL Server customer. No exaggeration, nightly ETL process, major logistics company. 3.5 hours to run this thing. They've tuned the code the best they can with what they have to work with. They decided to explore PMEM. App persistent on the storage, 20 megabytes. That's all they needed. Tail of the SQL Server transaction log. It took the nightly process from 3.5 hours to 8 minutes. If you can get that kind of bang for the buck, why wouldn't you?
That's impressive.
Well, you don't know that that's going to happen, I think is the big problem.
Right.
I mean, we could, in terms of when would you do this? The same way we do now, wrong most of the time. We'd give it a burl because we think it might be good, or honestly because the head of architecture thinks it'd be fun. And then we'll just suck it and see. Sometimes we'll have a great result. And when we don't, we will never speak of it again, and no one will ever know.
I think that you're right. It is hard to predict, but I think that if I'm sitting and thinking about it, and we actually underwent this process, is that Optane DCPMM or the memory form factor, it comes in relatively large capacities. So I think that if my application can't take advantage of all of it, or David gave an example of only needing 20 megabytes of it, then it's a trade-off, right? If you don't need all of it, then can you use memory mode, or can you use a different technology? But if you can actually adjust your application, or your application natively can make full use of it as effectively either cheap memory or persistent memory, then it's cost effective and it's probably worth the effort.
I guess the thing is for us kind of infrastructure people like me, I wouldn't know with regards to the application. So from my point of view, it would the differentiation between the two would be whatever the application developer says they need, right? So I need to architect my environment to fit their application needs. So if they require this mode or that mode, I just enable it as long as I can provide them with it. And then, so I'm guessing we're kind of heading into the part where the infrastructure people just have to kind of give the applications whatever they require, right? That's what they're doing through vSphere, and that's what we're doing through this, and splitting it up in namespaces and everything for that part as well. So it's a matter of the infrastructure actually supporting whatever the application requires and needs to run optimally, and then someone else kind of gets to figure out if it works or not.
I think the crux of the question, Steve, whether you should use AppDirect or MemMode, it depends on whether you think you can gain an advantage by controlling what's in DRAM versus what's in PMEM. If you can gain some performance advantage or cost advantage by doing that control, then AppDirect is the way to go. And if you can't foresee any significant advantage from that, then you just go MemMode.
Here's an interesting thought. What if you're running a VMware cluster with a VM that needs PMEM? The PMEM is in one of the hosts, but what if the VM needs to vMotion to another host?
Well, I guess that's the problem with anytime you've got specific hardware requirements, and that's why we need, composable infrastructure, right?
Yeah.
So this leads us to the next step along the path, which is, so the nice thing about the Optane AppDirect versus memory mode is that it's the same hardware. I mean, you use it how you want to use it. Then there's the question of Optane as SSD. And this, I think, is another similar question. If you want to use Optane as storage, when do you decide? Well, how do you choose between PMEM and SSD?
It's latency. I mean, an NVMe SSD, whether it's Optane or not, has higher latency than PMEM. PMEM is accessed on a memory bus. It's nanoseconds. The NVMe is microseconds, orders of magnitude. This is a different tier now because of the performance difference.
Well, there is also the capacity difference.
Which is like going from single cell to TLC or QLC.
Which also, just begs the thought of other tiering combinations as well. It doesn't necessarily have to be either or, right? If you need capacity and latency, you also have options.
Yeah, and when the comment was made about it's accessed on the memory bus, I think this becomes kind of less of a question as other technologies evolve. Direct storage APIs are now a thing. Giving you direct access from a GPU to the storage bus. There's less latency in that. There's a lot more use cases and there's a lot more nuance. And I think depending on what you need to do with the data is going to dictate where you put it in the bluntest possible term.
I know for Deos, right, it wasn't just about the latency to the DIMM itself. It was also its byte addressability, right? So that you didn't have to do as much locking to access small bits of data in parallel. So even if you had the same latency between the Optane SSD and the persistent memory, that persistent memory still plays an important role.
I think that there's also an interface simplicity. I mean, if I'm an application, I want to leverage an Optane SSD, either I need to now manage blocks, or I mount a file system on top, and then I'm up to what the file system gives me. And there's a variety of file systems. With a memory interface, I can have an AppDirect. I can mount a file system on it as well, but I can also have direct mapping for memory, which is simpler in many cases. So there's also, from a software interface perspective, advantages to either use case.
And this is undeniably true. I mean, as Justin said, it's a historical accident that there's a difference between memory and storage. It was based on, historical technologies. And the same is true of these interfaces. It seems to me that, one of the big deciding factors is, quite frankly, can your system even support Optane as memory? And if it can't, then guess what? You're going to use SSD. Use it as storage. And of course, there's another layer to the pyramid that we've seen, which is the NAND flash layer. And as Justin said as well, we have to start thinking about different characteristics, reliability and redundancy and so on for the the different types of NAND. So you've got QLC and TLC. How would you choose between those? And maybe the question goes to some of the people who've implemented it. So, or those who've architected the system. How did you look at that when you were looking at Deos or vSAN?
So how did we look at between QLC and TLC? Is that the question? Yeah, well, actually, honestly, we look at both, right? So today, when we look at our architecture, TLC is the most common to use together with the persistent memory. But, we've been looking a lot at using QLC drives with Deos as well, since the persistent memory takes a lot of the small writes and IOs off of the SSD, since we leave them in the persistent memory of a storage device. It has some interesting implications on the endurance. There was actually even a white paper that was published recently about looking at Deos and QLC drives as well. So that's actually an area we're continuing to explore. And actually also the impact of looking at 3 tiers is something we're exploring. Like if you have persistent memory and then you have a couple Optane SSDs as an in-between tier, then the ability to have QLC drives for the bulk of your capacity storage starts to become a more feasible option. So, I don't think we necessarily had to pick one or the other in our specific case. We wrote both.
Yeah, and especially in kind of vSAN settings, the endurance rating for the cache layer is one of the things we have to have in mind as well, because there's quite a big difference between the two there, which is why I guess most vSAN deployments do use
QLC.
QLC, yeah. No, TLC instead. Basically just because of the endurance rating for the cache tier, which if it fails, the disk group goes offline. So you need to make sure that is as endurable as possible.
Yeah, so I think that's what I was highlighting while I was talking about. So there are some additional, I would say, cushioning needs to be done on top of when you are using a QLC device as part of your persistent storage. And that's something we are kind of exploring on that line. So TLC, as you rightly pointed out, has definitely higher endurance. And I think one of the QLCs possibly bringing in the large capacity as well would be in direction where some large storage dense configurations where QLC may make more, potentially a good candidate come relative to a TLC device, but that's all has to be looked at holistically in that.
I think Enrico made a good statement earlier today, which was it's not just performance that dictates the tierability or separate tiers, but it's also capacity, and there's a distinct capacity increase as you get from SLC to MLC to TLC to QLC. I mean, and that capacity increase could dictate that it be a separate tier in my mind, even though it might still perform an NVMe over fabric sorts of latencies,
Yeah, it's all trade-offs, isn't it? All through this stack. And that's, I think, if we go back to what we saw at the very, very beginning, the whole point of this hierarchy is that we're trying to decide between the various aspects: capacity and performance, latency, cost, of course, reliability, everything, all the way throughout the stack. And I think that that's what we've seen here as well with some of those choices that have been made architecturally when you look at vSAN, or when you look at Lightbits, or when you look at Deos. It really is trying to weigh those compromises and compatibilities and performance and everything, and decide what makes sense for this exact piece. And another thing that strikes me as well is, there's really no such thing as hopefully an all QLC SSD. I mean, all SSDs have some kind of cache on them, and the highest performance SSDs now have DRAM and Optane right there in the SSD, as we've seen pretty remarkably with some of those Intel Optane SSDs that combine these things. So there's a mix even within the storage devices. So any final thoughts on the memory and storage hierarchy from the folks here? Is it really Do we have two-tier memory between DRAM and Optane? Do we have multi-tier storage? Or do we just have a smooth progression from the top to the bottom?
Sounds like the answer is it depends, which is a good consultant answer.
Well, I guess it depends then. Thank you very much, Justin. Any final words from anyone before we wrap up today with Intel? We have reached the hour. Thank you very much, Intel, for this. It's been great to be able to have some time to do our roundtable discussion here at the end. Nice to hear some voices from the delegates as well. And we will be back tomorrow morning at 8 a.m. Pacific time with more Tech Field Day.